You should be able to hear me better on the videos now. Now, what did we leave off with last time? You got to help me out.
That's section 1.2 we were doing a problem.
Well, let's just go to the homework. And I don't know if y'all sent any to me or not. 1.2.
Yes, sir.
You remember what number it was?
It doesn't say. It says.
Okay. Well, let me just look and find out. I think we did one like this, didn't we? I think we were going to work on one. Go ahead and write this one down. This is number 9. I think we were going to do one like this. It says the average classroom teacher salary is given by f of x is equal to 979.05x plus 32,907.47, where x is the number of years from what?
1990s.
So you need to highlight that right there, because that's important.
How? Yeah. How much? Where is this? I have to write it down.
Number 9 on the homework, 1.2. See, right here.
Yeah, it's on the.
1.2, number 9.
Yeah, I see that, but like, you're supposed to write it down.
Well, yeah, because we're fixing to do it. And that way, when you get to the homework, when you do it in the homework, you'll have it. Or you can print out your homework and look at number 9, and it'll look like this, only it had different numbers.
Anyone's way, can everyone see? Don't want to be in anyone's way.
You're not going to be in anyone's way. They can move just like you. All right, so I'm going to write it for you. F of x is equal to 979.05x plus $32,907.47. So there's your function. And they say for x is the number of years from 1990. So what is that called? It starts with an E. Experience. So, what input corresponds to 2005? Well, that would be 0 to what? 15. So x is going to be equal to 15. And 15 represents 2005. plug and chug. So let's plug in 0. That's simple. What would you get?
32,907.40.
Okay, so that's your base salary right there. In other words, if you come in right out of college, you would get $33,000 a year. But 15, we'll plug that in, and that's going to be 979.05 times 15 plus 32,907.47. Somebody calculate that for me. What does it come out to be?
47,593.22.
47,093. 593. What?
22
Point what?
22.
22. So if you have 15 years experience, you're making $48,000 a year. So here would be, let's see, output corresponds, 1990 would be 32,907.47 and 47,593.22. And that's how you do that. And you can do a graph. And let's see, from 32,000 to 47,000, you just need to look at the graph. Let's look and blow this one up. Let me move this over. 10, 20, 30, 40, 50. So there's 32, so that's a possibility. What about B? That's not a possibility. Why? It starts off at 40,000, so that's not it. B's not it, so you can count B out. This is what?
Too low.
8. That's too low. That's 18,000. And that one starts 10, 20, 30. So it's either this one or this one. And it looks like to me it's this one because this is about what? 50,000. Wait a minute, let's see. We might have to blow them up. Let's blow them up and see. Well, I'm trying to get there. There we go. Let's see. Let me take my handy dandy line maker. Well, that one's less than 50,000. Oh, that's 5,000. So that's not even it. I thought it was 50,000. I'm sorry. So that one's not it. So it's got to be what? A. And you feel good about yourself. That's a test question. So you might want to mark number 9 as a test question.
Kind of confusing.
What are you confused about?
That last bit, what was that with the graphs?
It's the graph of these two numbers right here with 0 and 15. 32,000 is right there at 0. And 15 is at 47,000 right there. And what they're trying to teach you here is how to exclude what? How to exclude the inevitable. What's wrong with this one?
Too high.
It's too high, but it's also what?
Straight.
A straight line. That's not right. This one starts to what?
Low.
And this one
Numbers.
Just off.
is way off. So they're just teaching you law of deduction there. All right, that's a test question. All right, try that one. Write that one down.
What's this one?
Number 10. Says the projected population of a region for selected years from 2000 to 2060 is shown in the table on the right with the population given in millions. According to this table, what will be the region's population in 2030? Well, 351 million, 0.5. Create a new table with X representing the number of years after 2000. So in other words, 0, 10, 20, 30, 40, 50, 60. Using a graphing utility to graph the data from the new table as a scatter plot. So what we need to do is you can go to the Excel spreadsheet and you can make this, or you can do it, I'm going to do it in an Excel spreadsheet because I like to use Excel. You do it in your calculator, that's fine also. I don't care. Create a new table. So we're going to do that. 2000 would be 0 years. Let me make this a little bit smaller. Zero years. What would 2010 be? 10, 20, 30, 40, 50, and 60. And the million, I'm just gonna, 273.5.
Wait,
Hmm?
what's with the B and C stuff?
What are you talking about?
You're making a chart, right?
Yeah, on Excel.
Oh,
Okay, you do it on your calculator. 301.06. Probably 0.6. 324.6. 376.5. Wait a minute, I think I skipped one. 351.5. 376.5. 405.5. And 430.7. You wanted to do a chart plot. You go up to data. I think it's data, no. Insert. You can go to insert, and right in here is your charts. There's your scatter plot right there. And there's your chart. That's what it's going to look like. And I forgot what the question's asking. You can do this on your calculator by going to table, and filling out the first two columns, and then it'll also, you can go to chart, and there's your chart right there. Let's see what the question's asking again. The question says, according to the table, the region's population will be what in 2030? 351.5. So 351.5. Okay, I'm not writing it in millions, I'm sorry. I'm not doing that. And then they're telling you to fill out the chart here. This will be 0. We've already done this. This will be 20, 30, 40, 50, and 60. And 10 would be 301.6. 30 would be 351.5. And 50 would be 405.5. And that's it. And what does the chart plot look like? Well, look at ours. There's what mine looks like. Make it a little bit bigger for you. So it starts up here in just kind of straight lines. So let's look over here. Which one is it not? There's two there that it's not. A and D. Why?
they're going the wrong way.
Because it's a negative correlation. We got a positive correlation.
With the numbers at the bottom, how do you know which one's X and which one's Y? Where it says 0 by 60.
That's your window settings. That's not, it's just settings for your window. I'll show you that in just a minute.
So doesn't that mean if the 60 one's first, then it's on the
That-
x-axis or anything?
This is, okay, this is your window setting to see the graph. Just hold on just a second and I'll show you. I think it's C. The reason I think it's C is because this one's starting from right there. It's not even starting at 0. So I don't think it's this one because it's not starting at the right place. So I think it's C. And that's it.
Wait,
Now,
what's that thing that says like,
250, 500.
that's what I'm fixing to show you. That's what I told Ms. Foster just a few seconds ago. Okay? Now, you can take your handy dandy calculator. And you can punch those numbers in, go to table. Oh, excuse me, I'm sorry, I can't even remember what table it is. List, second function stat. And L1, no, edit, I'm sorry, second stat. Well, wait a minute, where is my, I don't use the calculator very much.
and for window?
Is it window?
Yes, window.
Yeah.
No, that's not it. You gotta put the table, there it is, table. No.
Second line.
Okay, table. All right, so 0, what's the second one, 10? What's the third one? 20, is it 30, 40, 50, or what?
36.
Okay, it's not, okay, 0, 10, oh, I've gotta use this, I can't use the,
How can you change?
it's supposed to change, I don't know
I don't
why it's
have a
not
graphic
changing.
calculator.
And the last, and
It what?
and
Wait a minute. Oh, something's already in there. No? There's another place where you edit the list. And it's supposed to be under list. Edit, there it is, I knew there was edit, I must have not have hit that while ago. There it is, okay. There's second list, or second stat, and then edit. And then type in 0, 10, 20, is it 30, 40, 50, and then what? Is that it?
What if we don't have a graphic calculator?
And go to Wabbit EMU on your phone and download one. All right, what's the first one? Didn't I write that down on the board that day? Did I not write? I don't know what I wrote down with y'all or not.
I think you did.
You did.
Yes,
Wabbit EMU.
Mm.
Yeah, yes.
All right, what's the first one?
273.5,
273.5.
301.6, 324.6, 351.5, 376.5, 405.5.
All right, there it is. Now, if you want to do a scatter plot, go to stat, calculate. Okay, that's not it. It's I'm sorry. Second y is equal. Second y is equal. Plot on, hit enter. You gotta go in and hit on. We want a scatter plot using L1 and L2. Everything's set. Hit enter. And graph. Now, you notice you don't see anything. So you hit zoom. 6. Maybe we can get it there. So you still can't get anything. So then you go to window and you need to put in some numbers for the window. Now, in the problem, it gives you a hint. It says window needs to be 0 to 60 and 250 by 500. All right? So 0 to 60 and 250 by 500. That's your X min, X max. This is your Y min, Y max. So 0 to 60, 250, 500. So go 0 to 60 And then what's the other one? 250 to 500. There they are. Now, what if you didn't know those numbers? Well, if you didn't know those numbers, zoom, 6, there they are. You still don't have them. You zoom out until you find something. Zoom out. You know they're going to be in the first quadrant because they're all what? Positive. And put it in the middle of that section and just start hitting enter and then zoom out again. And eventually you'll get to it. But also think about this. Look at this right here. What is your first point? 0, and what's your y?
276.
So you know that your y min has got to be around 270 for you to even see it. So that's where they get the 250 right there. That's where they get that from.
It seems as though like it roughly jumps up by 25 each time.
Mm-hmm. Yep. Pretty much. Okay, who's got a question on that one? This is just a drill for the calculator. That's what this is. Or the Excel spreadsheet, whichever one you want to use. Okay, that's 1.2. Let's look it out. Let's see what else we got on 1.3. Homework 1.3. And let's look. We're still in functions because I covered a lot on those first times. All right. Write that question down. This is number 1. Now this is a test question. Oh. This is a test question. So write it down and go ahead and take a minute and try it.
This is number 1.3.
1.3, number 1. What is another word for rate of change? Anybody want? It's a one word, one short word. Slope. Find slope. Now, for those of you who don't remember how to find the slope, I'll put it on the board for you. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And which way do we read? Left to right, Hubert. That's right, class.
So this is x of one, this is y sub one, this is x of two, this is y sub two. Plug and chug. I always tell my students to use parentheses. Why? Why do I tell students to use parentheses?
They don't get confused.
Because of these guys right here. What do they cause?
Chaos.
They cause trouble. So plug and chug, see what you get. What's y sub two?
Negative.
2. What's, sorry. Put the wrong one. Y sub 2 is
Negative 1.
negative 1. Y sub 1 is 2. X sub 2 is 8. And negative what?
6.
And negative 1 minus 2 is negative 3. And 8 plus 6 is 14. So your answer is negative 3 14ths. And that's a test question. You'll have 4,000 or 5,000 of those on your test. Because if you're a business major, you better not walk into a meeting and not being able to find the slope of the line. They'll laugh you out of the meeting. All right, same type question, except it's got kind of a twist to it. It says, total fall enrollment in a 4-year college for the years 1990 through 2008 is given by blah, 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 blah. Where X is the number of years after 1990 and Y is millions of students. Is this a linear function? Why or why not? Okay, read it again.
Wait, it's like the one before the one we did, or the first one, like that we did.
This is a question that it's asking, is this a linear function? Is it a straight line? And I'm fixing to tell you how to tell that if you don't know. So what I want you to do is I want you to get a piece of paper in your notes. And I want you to section it off like this, sideways. And then we'll go back to the question, and then you can answer it. So take a piece of notebook paper in your notes, or turn your notebook sideways, and draw it into sections like that. That's one piece of paper. And
A whole
first
piece
one
of-
will be
a whole-
called,
A whole piece of paper?
yeah. F of x will equal x to the first. F of x is equal to x squared. F of x is equal to x cubed. F of x is equal to x to the fourth. F of x is equal to the square root of x, or x to the 1/2. F of x is equal to the absolute value of x. And we'll stop there. Or f of x is equal to 1 over x. And f of x is equal to 1 over x squared. And what I want each of you to do is try to recall from memory what each one of these look like. So, draw you a little graph, and then if you can't do it, that's fine. Try to remember what the graphs look like for all of these, or fill in whichever ones you can. Just sketch it. See what you come up with. All right, so the first one, anytime you have x to the first power, you're going to have what kind of a line? A straight line, which means linear. Anytime you have x to the first power, you're going to have a straight line, which means linear. Anytime you have x squared, it's going to look like a horseshoe. And that's a parabola. 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 Anytime you have an x cubed function, you're going to have half of a parabola, and the other half going the opposite way. There's half of the parabola, and the other half's going the other way, where this one's going up, this one's going down. That's a x cubed function. Fourth, x to the fourth is going to look just like this, only the bottom is going to be more what? It's going to be more squared. Oops. Like that. It's going to look more like a U than a horseshoe. A square root function is going to look like that. Absolute value, absolute vodka. Value and vodka start with a what? Always looks like a V. I bet you won't forget that one on a test. Alcoholics. I'm just kidding. Huh? 1 over x? What'd you say?
You don't drink.
Oh, okay. But I bet you'll remember it now. Looks like that. And 1 over x squared looks like a volcano. Oops. This is called the parent graphs, or the family of graphs, whichever one you want to call it. From now on, when you see a function and you look at the x, look and see what it's raised to. If it's raised to the first power, it's linear. If it's raised to the second power, it's a parabola or parabola. If it's raised to the third power, it's half of a parabola, the other half going the opposite direction. If it's a quartic function, meaning a even, it's going to start squaring off on the bottom. Instead of looking like this, it's going to be more squared. X to the sixth function will be even more squared. Square root function, or x to the 1/2, is going to be like a swoosh. Absolute value, v, and then these two, you're going to see them later on. You can actually go and Google parent graphs and print out a good rendition of this. So, let's go back to our question. What is this function?
Priority 1 message coming in on secure channel.
Is it linear? Why? Why is it linear?
Just as x.
Because the function is linear because each of the variables x and y appear in the first what?
Power.
I just told you that. So the answer is C.
It's always confusing when it's a question, when it gives you a question that you're not supposed to answer.
Yeah. All right, let's try nerd. We got to check this. Okay, what's independent and what's dependent?
X is independent.
X is always what?
Independent.
Independent. And Y always depends on X.
You know, that kind of helped me in with some biology homework, actually. If they like show.
They ask that
graph,
all the time.
and it's like, which is the independent variable, which one's the dependent variable. And if x is, if y depends on x, that means that x must be, that like,
The independent.
yeah, if it's showing a graph.
In other words, X can stand on its own. Water is water. Okay? Water does not depend on the ice machine. The ice depends on the water. Always remember that. Was that a test question? Probably not. The first one we did was. Let's try that one. That's a test question. The life expectancy of American women 2 years after 1960 is given by A of t is equal to 0.2t plus 73. Is this function a linear function? What is the slope of the graph of the function? Interpret the slope as the rate of change. So just do it on paper. Don't worry about what it's asking up there. Just do it on paper.
Wait.
You have a work email.
Well, you know it's linear because t is raised to the what? First power. So, you know it's a linear function.
Priority 1 message coming in on secured channel.
What is the slope of the graph of the function?
0.2.
0.2 is the function. Exactly, 0.2. So that's 2 over what? 2 over 10, exactly. And you need to think of it like that. It is a linear function. Y is equal to mx plus b. Y is equal to 0.2x plus 73. And there is your slope. 2/10. M is equal to 2/10, or M is equal to 2 over 10, which is what? 1/5. Because you have to have vertical over horizontal so you'll know how to graph it. And that's what they're asking you, that it is a linear function. And check it. Yes. The slope of the graph is, I'm going to put 1/5 because I'm a math teacher, and I think you ought to put, 1 over 5, but it may 1.2. I'll take either answer on the test. The rate of change is 1. Oh, okay. I didn't know where it was going. So what is that? Okay, hold on. What is the rate of change? Let's look again. The life expectancy of American women 2 years after 1960 is given by A of t is equal to 0.7 years. So years, right here, is your x. Years is x. So as years go along the x-axis, oops, can't draw with a mouse. As the years go along the x-axis, what's the y-axis? life. So this is horizontal, and this is what? Vertical, so it's life over what? One life expectancy every what?
5 years.
Every 5 years. And that's what it's going to ask you, something to that effect. So I don't know what it's going to ask you. The rate of change is 1, that's what I would do, 1 life expectancy per the years after there. That's what I would say. I don't understand the question, so I'm just going to hit it. Point 2, okay. Point 2, I did 1/5, they did point 2. That's, okay, just put point 2. That's all you have to do. Point 2, years of age per year after 1960. I was putting 1/5. So, point 2 for the years of what? Life expectancy. Right here. So the graph is 0.2, so that means it's going something like 2/10 would be 1 vertically, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks something like that. The first 2 questions is test questions. I wouldn't ask you that third one. That was kind of confusing.
Is number 1.1 number on 1.1 question 5, is that a test question?
I don't know, we're on 1.3 right now. I can look at it in a minute. We'll look at it in just a second. All right, look at this one. A company charting its profits. Notice that relationship between the number of units sold, X, and the profit is linear. If 500 units are sold in blah, 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 and blah, 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 results in blah, 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 find the marginal profit, which is the rate of change of profit. So they want you to find the what? Slope. Find the slope. Find the slope. Okay, thank you. So, where is our X and Y? Well, first one, we've got 2 points. 534.52. And 575. And 82.52. And x of 1, y sub 1, x of 2, y sub 2. Y sub 2 minus y sub 1 over x of 2 minus x of 1, parenthesis minus parenthesis over parenthesis minus parenthesis. Y sub 2 is 82.52. 34.52. 575 and 500. I'll do the bottom for you. And what's the top? I have no idea. It looks like an even 100 or something.
4,800.
4,800. And somebody divide that.
664.
Huh?
It's 64. 64.
This comes out to be 64 over 1.
Yes.
So that means 64 up and what? 1 over. So we have a pretty steep what? Pretty steep line. So what does that tell you about the profit? Profit's pretty good. That's what it tells you. It keeps going what? But always remember, what goes up, what? Must come down, exactly. All right. Now, what section is this?
1.3.
All right. So, what y'all need to work on for homework, and that way y'all can send me questions, is start working on 1.1 through 1.3, and then Thursday we will work on homework questions that y'all send me.